Friends, today I wanted to introduce to this two problem. Again, I am taking this problem from Sarchilang book, and I am trying to solve by my own. I have seen some internet resources for the solution cross checking. Without further ado, let us do this problem. It is a very simple problem solution. So that solution is very simple. You have to all cross multiply, just cross multiply and verify this becomes very easy. So z minus 1, okay, 1 plus z plus dot 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 plus z power n is nothing but you will get it like first you multiply with z, so z square, so z power n plus 1. Now you just multiply with minus z power n, so they will get cancelled. So here the z square will be there, they will get cancelled, so you will get z power n. So finally what you have is z power n plus 1 minus 1. So this is what we have. So we have verified when we multiply, and the thing is that z not equal to 1 implies z power n plus 1 minus 1 by z minus 1 equal to 1 plus z power n, and it will be used in many contexts, especially in power series later on the classes. Okay, so using this idea, what we are going to do doing this problem, using the previous problem, taking the real part, prove this. Okay, this is a Sarchilang problem. Again, you can go and see in his book. So how to do this? Okay, so that just replace by z the real part of the sum. Okay, let us look at this thing, k equal to 0 to, so solution, look at this, k equal to 0 to n e power I theta k, replaced by e power I theta. So it is we know the real part. When we take the real part of this is 1 plus cos theta cos 2 theta cos n theta, using de Moivre's theorem, and just you can use the sine and cos defined through the e powers, that exponentials. Okay, but at the same time, when we use the last problem, and we know when we sum up this thing individually, k equal to 0 to n e power I theta power k, we are getting e power I n plus 1 theta, the nth term, by e power I theta minus 1. So this is z power n plus 1 minus z. So instead of z we are putting e power I theta. So okay, what is this? And we have a good idea about this. Okay, so just take like the next step is very simple. This is n plus 1. You all going to know this. This is like I'm taking the half away. Okay, just take the half in both the cases. That means e power 1 by 2, theta by 2. Just take this thing both the case, so minus e power I theta by 2, and the same thing, and when the numerator and denominator taken away, both get cancelled. So here e power theta by 2 I theta by 2 minus e power I theta by 2 minus theta by 2. So we know this. Now this formula is kind of clear what we are heading towards, kind of clear. So the down, at least in denominator, is very clear, n plus 1 by 2 theta, okay, e power minus I theta by 2. This down one is 2i sine theta by 2, and this 2 will, it's like 1 by 2, I will come out that side, and there is a minus sign, and if you multiply with the minus sign, you will get this. Okay, very good. Okay, fine. So if you just see the imaginary part comparison, once you see this imaginary part comparison, you will get the idea, right? You just see the imaginary part. So the imaginary part of e power minus I theta by 2 minus e power I n plus 1 by, e plus n plus 1 by 2 theta is sine theta by sine minus theta by 2 minus sine n plus 1 by 2 theta, hence 1 plus cos theta plus cos 2 theta plus dot 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 plus cos n theta equal to sine theta by 2. We know the sine minus theta does not change anything. It's all silver teacups things. You can see all silver teacups. Using that, you can see that it's very easy. So this is sine n plus 1 by 2 theta. So totally divided by 2 sine theta by 2. Okay, so this is a desired formula that we get it. So you just see this thing, and just I always tell you try this solution, and if not, you come and see this video. Okay, so thank you for listening. I will see you in the next video. Thank you.